Hello and welcome to another Godot tutorial. In this video I'm gonna tell you all about the NavigationRegion3D node and the NavigationAgent3D node. Pathfinding. Yes, we're gonna figure out pathfinding in Godot. This is a follow-up video from the last one. We are going to apply the pathfinding on the grid map that we created in Blender. But don't you worry, this is also a standalone video. You don't necessarily have to watch that video. You can also apply the pathfinding part on your own level. In this video, we're gonna make enemies roam our little grid map in a random fashion. They're gonna take into account all the blocks, they're gonna walk around and beneath blocks. It's gonna be awesome. And make sure to subscribe if you don't want to miss the third one in this series, because we're also going to add player detection to the enemy node. Alright, your project should look similar to mine. The only difference is that I made the grid map slightly bigger. Before we continue, let's clean up the project, just slightly. It's not going to take long. Let's go to the character body 3D branch of nodes and rename it to player. And also save it to a separate scene. You can do that by right mouse click button on it, and then if my face is not in the way, click on save branch as scene. And let's also name it player. I really must be the most annoying Godot tutorial creator on YouTube. I won't say player again. Trust me. The scene already had a code file attached to it, and it was in the scenes folder. It was called character body 3D. You know, let's also rename it to player. We'll be working on the script of the enemy, and we'll be putting all those files in a folder called scripts. So go to the root of the folder, say create new folder and call it scripts. And finally, let's just drag and drop the player.gg to scripts. Let's start with the boring part by creating a pill-shaped enemy. We're going to create a new scene in the folder scenes by right mouse clicking on the scenes folder and click on scene. Click on this item, so we are creating a very specific scene called character body 3D. Double click. We're going to call it enemy and press OK. Let's create a script file for the enemy scene by clicking on this icon. We're going to put it in the scripts folder that we just created. The file name enemy.gg is just fine. And because we are super lazy, we're going to check the template here. And then we're going to delete everything except for the gravity. And our enemy won't be jumping, so we can remove this one and we can also remove this one. Yeah, we save so much time with this. Go back to the 3D view and now you'll see that we have a warning here. It doesn't have a mesh, it doesn't have collision. So let's change that by clicking on plus, search for mesh instance 3D, add it, go to the mesh property in the inspector, select the pill shape. And let's give it the same dimensions as the player. So click on the pill shape and give it a radius of 0.25. And if I remember correctly, 0.9 for the height. Let's add a collision shape to it as well by searching for collision shape 3D and then pill shape. Make it 0.25 and 0.9. You can also create collision by just selecting the mesh instance 3D. And then go through this button, create collision shape. But I always forget it. I always do it this way. Doesn't matter. We've got ourselves an enemy with a mesh and collision. Let's go back to the main scene and let's add the enemy to the world. Whoop. And I realized that I haven't even resized the player yet. I thought we did that. Go into the scene of the player, open the player scene, click on the mesh instance 3D. Make it 0.25, 0.9. Same for the collision shape. Amazing. And now we've got a player and an enemy, and they can both go below the blocks over here. Super cool. Maybe to differentiate the enemy a bit from the player, let's open the enemy scene like this. Go to the mesh instance 3D node and search for material surface override. It should be somewhere around. Oh, it's called surface material override. Click on new standard material 3D. Click on this one. Search for albedo and then make it a pretty color blue. Because in the third video of this series, we're gonna make the enemy red whenever it sees you. And we are super smart, you know. We prepare those things beforehand. All right, this is where the magic starts. We're gonna add a NavigationRegion3D node to the main scene. Click on the root node and press plus and search for Navi. And then you need the NavigationRegion3D node. For some reason, I really like this one to be on top of the branch. Doesn't really matter. It has a warning. It says that it needs a navigation mesh resource. Do that by going all the way over here in the inspector and click on a new navigation mesh. You can open it, and here you can change all sorts of settings. We're going to touch upon a few of those later on in this video. The easiest way to create a navigation mesh from the grid map is by simply drag and dropping the grid map into the NavigationRegion3D node. Just like this. And now if you click on the NavigationRegion3D node and press this button, Bake Navigation Mesh, your Navigation3D mesh will be generated based on the grid map. If you go to the inspector of the NavigationRegion3D node and you go to this one, you can also change it so you can create a mesh based on specific meshes that are in a group. But for the sake of this video, this option, root node children, will do just fine. Just make sure to have all your objects in the NavigationRegion3D node. And as you can see, the navigation mesh floats above the grid map. That is intentional, because whenever players are on the ground, it will be moving towards an area, towards a spot in the mesh. And let's say the navigation mesh is on the ground, the character will go downwards as well, and therefore it will slow down. So generally speaking, it's best practice to have the mesh in the middle of the agent's height. The next part is very important because the navigation mesh doesn't go around the blocks and also not below the blocks. And that has everything to do with the agent settings here in the agents group. We need to tell the Navigation3D node the height of the agents. Let's say we make this around 0.7 and then we press the Bake Navigation Mesh again. You'll see that the mesh goes below the blocks. So by changing this height property, you basically tell the mesh how big the agents are, and then it can figure out if they're able to go below it. The same goes for the agent radius, this one. It now says 0.5 meter, and therefore the characters are not allowed to go past these blocks. They're too fat. Let's make them a little bit slimmer by putting it to 0.25 and say, yeah, all right. We bake the navigation mesh again, and now the enemies can go around and also below the blocks. And that's basically it for the NavigationRegion3D node. There are a few things that I can touch upon real quick here, which is probably the max climb and max slope. Those are very useful. Let's say characters should be able to walk on a staircase or any other mesh that has a specific height, that you can change the max climb property over here. Let's say I put it on 1.5 meter and I bake the navigation again. Now it's able to climb on these meshes. I'm gonna put it back to 0.25. The max slope is also very useful. Let's say you have certain ramps or slopes with a slight degree of rotation, then you can change this value to tell the NavigationRegion3D node that it should be able to walk on the slope. Again, I always advise to just right mouse click on the properties and go to the documentation and learn about all the different settings. Alright, so we've added the region for the enemies to walk in, but now we need to give the enemies a brain. And we can do that by opening the enemy scene by clicking on this icon yet again. Go to the root node and search for navigation, it should be called, NavigationAgent3D. Let's put it all the way on the top. It's a rule, you cannot do it any other way. And these are all the nodes that we need. A NavigationAgent3D node, a mesh, and a collision. All right, let's click on this icon. Let's work on the code of the enemy, the most important part of this tutorial. Let's put a comment over here first called constants, and then followed by another comment called states. Yeah, we're not going to use a behavior tree for this tutorial to keep it all simple. For simplicity's sake, let's just make a enum here called state, these brackets, and we're gonna have an idle state. We're gonna have a waiting to move state and a move state. The waiting to move state is completely unnecessary if you're actually using a behavior tree. If you want to learn about a behavior tree, I've made a video. I will link it somewhere. And the default state will be idle. Another one, timer. We're going to be counting how long the character is waiting to move, and therefore we have to store a variable called idle wait time. It's going to be a float, and the character is going to wait for 1.5 seconds before it starts to move. Let's just call it wait time. The other one's going to be idle timer count, also a float. Geez, I cannot type today. Again, it's all going to make sense in just a bit. Let's say internal countdown timer, something along those lines. All right, the node references. The code needs to be able to reach the brain of the enemy. Simply do that by dragging the NavigationAgent3D node while holding Control and have this onReady variable called NavigationAgent3D. Between the velocity and move and slide, we're going to add the makeshift behavior tree. We'll do that by typing match and then state. And whenever the state is idle, we're going to print idle. Whenever the state is waiting to move, we're going to print waiting to move. And when the state is move, we're gonna print move, print. So since the default state is idle, and when we are going to test the game, we're gonna have this constant idle output right over here. But instead of just printing the state, we're gonna call the methods for the actual states. Let's type function on idle, and then we're just gonna put the print over here, and in the idle state we're gonna be calling the onIdle function. Let's copy this 3 times because we are super lazy. We're gonna print the waiting to move, and we're gonna print the move. We're gonna change this one to on waiting to move. Put the method here, and this one's gonna be called on move. Here we go. And if we play the game, it works exactly the same, but now we've prepared some sort of clean logic to put all the code in. So I don't think we need the physics process anymore. So you can also hide it a bit, to make it all clear and have a nice overview. Whenever the enemy is in idle mode, we're going to make sure that it's not moving. We're going to change the velocity by adding a vector 3 and 0 to it. So this way we are sure that the enemy stands completely still whenever it stops moving. Every time when the character is in idle mode, we're going to make it so that the idle timer count, which is this variable, will be set to the maximum amount of time it needs to wait before it can move, and that's this one. So we are setting the idle timer count to 1.5. And that's basically it for the idle state. We're going to change the state to state waiting to move. And for overview's sake, you can also hide this one. We're done with the idle state. Now we're going to add some logic to the state in between the moving of the enemy. We're going to be subtracting the timer count with the delta. We don't have a delta yet. I need to unfold the physics process one more time and also give the onWaiting to move function the delta parameter. And here we're going to put this one over here. And now once and for all, we won't open you. I promise. So in the physics process, whenever the character is waiting, we're going to be subtracting the idle counter. And whenever the idle timer count hits 0.0, let's print time to move. Right? As you can see here, Time to move. All right, whenever the idle timer hits 0, we're gonna make the enemy pick its next target right before going to the move state. We're gonna make a different var here. Let's call it target. And then we're gonna put a function here that we haven't created yet. And it's gonna be called get new target location. So let's create the function right below it. Get new target location. And here I'm going to copy and paste some code that I prepared. Don't you worry, I will explain it somewhat at least. We are basically returning a new position, a vector3 var, based on the enemy's current position. So in this case, the character will go somewhere in between 0.5 meter to 1.5 meter to left or right, or it goes 0.5 meter to 1.5 meter towards or away from the camera. And if it's not completely clear to you, just print the values real quick. Let's say current location, next location, amazing. And while we are here, let's also change the state to move. And if we play the game right now, you'll see that the game, yep, see? As you can see, here we have the current location of the enemy and the next location. The y-axis is the same because I don't want the character to fly whenever it's picking a different location. And we simply did that by putting a 0 in the offset y parameter. Let's remove these comments and let's add the actual target to the brain of the enemy. And if you remember correctly, we have a reference var of the actual brain node, the NavigationAgent3D. Copy this one and then type target position, and we'll be setting the target position with the newly created target. Done waiting, pick new target. The character now knows where they go, but now we still need to program the actual moving. So let's hide this for now and let's work on the move function. I'm gonna move this one over here. There are multiple ways to move characters and NPCs in Godot. In this case, we're just going to calculate the direction based on the current position of the enemy and also the target position that we set previously. We're going to be creating a variable called current position, and we'll be setting it with the global transform origin. So this is the position of the enemy in each and every single frame. Then we're going to be creating a variable called next position. And we're going to use our brains for this, literally. And we're going to go and reference the brain of the enemy again, the NavigationAgent3D node. And we're going to retrieve the get next path position. And since we now know where the enemy is and where it should go, we can also calculate a direction. Then you're going to add those, how are they called again? Parentheses? These characters. And we're going to say next position minus the current position. And then we're going to normalize it. And since we now know the direction of which the character should go, we can just multiply it with speed by saying velocity, direction times speed. Yeah, and I think this should work. Let's just lower the speed a bit. It shouldn't be 5. Let's lower it a bit so we can see what's going on. The character should move towards the direction. Yeah, whenever it reaches the position, it won't do anything at all. It's also a bit twitchy, but we're gonna fix that. The next thing that we're gonna do is that we're going to listen to the signal that the navigation agent can fire, and which is called target reached. I went a bit fast there, but just click on the NavigationAgent3D node, then click on node, and then go to target reached. Whenever you double click this and press connect, there will be a newly created function over here, which if we put print here, target reached, this should fire whenever the character reaches the target. Let's check it out. Yep, target reached. And maybe if you looked carefully, it was printing this message way before it actually reached the target. And that's simply a setting. Let's switch back to Inspector while you still have the Navigation Agent 3D selected. And I think click on Pathfinding. Yeah, there you go. And here you can set the target desired distance. And now it will already consider itself a target reached whenever it's 1 meter away from the target. So let's change this to 0.25. You can even lower it to your liking. Another thing that we're going to do is we're going to go to Debug and check the enabled property. Now we can see a fancy line whenever we test the game. See? This is super handy whenever you're debugging. So we can now remove the target reach print and just change the state back to, you've guessed it, idle. So now we've got ourselves this nice little loop. It goes to idle, then it starts to wait for a bit, then it starts to move, and whenever it reaches the target, it goes back to idle again. We can obviously test it out real quick. It goes here, it stops, it waits, it picks another location, and so on. Sometimes it picks a location that's not within the mesh, and then it doesn't reach the target. It's unable to reach the target because now it wanted to go inside of the blocks. And the same happens whenever it wants to go outside of the navigation mesh. So the red line, it doesn't go further than the mesh, but in actuality, the target lies somewhere over here probably. And it's just unable to go there, and therefore it will never reach the target. So sad. Let's fix that. So let's go back to the waiting to move state. Here we set the so-called raw target, the target that is possibly out of bounds or within a mesh. And here we're gonna retrieve basically a map that we can use to pick a safe target or a closest target within the navigation mesh. So let's just call it nav map. And we're going to call the brain once again, and we'll be asking for get navigation map. And now we're going to use the map and also the target to determine a safe target or closest target. We're just going to call it safe target. You can call it whatever you want. And we're going to be calling the navigation server 3D and then map get closest point. And this function needs the map and also the desired raw target. And now it's going to return a safe target within the navigation mesh. And last but not least, we're going to replace the old target var with the safe target var. And that's probably it. Let's check it out. Awesome. But now it will no longer try and go into unreachable meshes. See, it goes nicely around the blocks there. Super awesome. Let's duplicate a bunch of enemies so I can also show you the avoidance feature. Because now they are most likely bumping into each other. See, which can cause for like a messy result. And maybe this is the way you want it, to have some clumsy type of enemies. But in this tutorial, we're going to make it so that they will be trying to go around each other. All right, we are almost there. To make it so that the enemies will no longer be colliding with each other, we are no longer going to be setting the velocity directly here in code. Let's do that by just making the velocity a variable, and let's just call it new velocity. So we are now storing the velocity, but we're not doing anything with it. So instead of directly setting the velocity on the agent, we're going to set the velocity in the brain of the agent. I'm really hoping that I'm not making it way harder to follow with all the metaphors. And to make it so that the brain actually computes the velocity, we have to click on the Nodes tab once again. Make sure to have the Navigation Agent 3D selected and click on the velocity computed signal. Double click on it, press connect. And now we have the our Navigation Agent 3D velocity computed function. And right over here, we can actually set the velocity whenever the brain came up with a safe velocity. All right, there's still one more thing we need to do. Let's go to Inspector, make sure that you have the Navigation Agent 3D selected and click on the Avoidance enabled within the Avoidance property group. And if we read this one, it says when velocity is set and the processing is completed, a safe velocity vector 3 is received with a signal connecting to velocity computed. So now, finally, with this enabled, it will set a safe velocity whenever the brain has computed the velocity. And before we test it, let's put this on 0.3. The actual radius of the enemy is, I think, 0.25. But you know, ignorance is bliss. Let's just make those enemies think they're super buff so we can see the results a bit more clearly. And if we play the game, they will fall in slow-mo. I'll fix that in a bit. But if you look closely, all the capsules, the little pill-shaped enemies, will go slightly around each other instead of the clunky collisions. For the sake of this tutorial, I'm just going to put a if statement here which says is on floor, and now only the computed velocity will be applied whenever the character is on the floor. Therefore, the character will go in fast fall first, and only when it touches the floor, it will get its safe velocity set. Let's test it out. Yay! That's so cool. See, you can see the avoidance way more in action now. They somewhat push each other. They will force themselves through the crowd, just like we do when we go to a Taylor Swift concert. I obviously never go to Taylor Swift. I'm very manly. All right, that's it for the video. I hope you've learned a bunch. There are 2 more bonus tips that I want to share if you happen to have a good time here. If you go to the enemy and the navigation agent node and you go to the inspector, you can also change the desired path distance. Long story short, when you make this as low as possible, it will be respecting the paths way more. So it will less likely get stuck between corners. The higher this value, the more it will likely leave the mesh to take shortcuts and so on. Another tip is to slightly improve this line here by having the safe velocity move itself towards the safe velocity by a certain amount, and therefore it will push itself slightly, also to prevent getting stuck around corners or slight slopes. I realized that we didn't even have an agent going beneath the blocks here and around certain blocks. And as you can see, hopefully, yeah, some go very nicely around blocks. They go beneath blocks. And we've got ourselves roaming enemies. Isn't it cool? Alright, that's it. I really hope you enjoyed this tutorial. If so, give it a like, say something nice in the comment section. Also, make sure to subscribe because the next video we're gonna be dealing with player detection. We're gonna make it so that each of those bad boys will be able to see us, and whenever they see you, they will turn red and probably follow you. And with that, I wish you all a great day, and I see you guys around in the next video. Stream. Bye bye.